Morning, everyone. This is Lecture 20, the first part of process selection for Module 4. I'm Sundar Atre. Let's build off from the concepts of how selecting the right process or how we make things interface with what we make things out of, which was material selections. So, when we look at our familiar map of the design process, right, there is a market need identified, which translates into a method to deliver on that market need. And that leads to an overall product specification. The course has focused on how we go through some iteration between identifying that need and realizing that overall product that needs to be defined in terms of what it does, what it might look like, and how it might be made, and what are the implications in terms of performance and cost, in terms of sifting through various alternatives. So, we are focused on process selection during this module, and specifically, just like you had a materials universe in the Granta EduPack database, you have a process universe as well. And among that are listed a large number of processes, such as which are categorized based on Introduction to Manufacturing ME 381, joining, shaping, surface treatment, and assembly, which is the other aspect, right? And each of these general categories have multiple options, right? So, for instance, shaping, you would have, for instance, these half a dozen examples of how material is shaped. And within molding, for instance, you have another 5 different options that are shown here as an example. There are more categories related to that. And within that, you can then go ahead and specify things like what is the shape we want, what kind of constraints based on size, section thickness, tolerance, roughness, and quantity. You can provide the same shape in multiple methods, but the quantities might vary, right? The maximum size or the minimum size or the feature size could all be different. And the precision you can manufacture things to can also be quite different, right? So these details, just like you could click on any particular material and say that here are the details in terms of physical properties, mechanical properties, thermal properties, and so on. As attributes of this nature are provided in process records, and there are ways to be able to map this information out as well, not only within the process family but also across other material indices. So in this class we will look at the central role that processes and selection of processes plays as we deal with the other three corners of this overall triangle in terms of function, material, and shape. So the key thing to address is the fact that there are certain shapes that can only be made by certain processes. There are certain materials that can only be converted to those shapes by a certain subsection of those processes, and the combination of those allow us to then deliver on particular types of function for a design. So the process selection principles, what are they? How do we screen through options based on material compatibility, shape compatibility, size restrictions and constraints, precision constraints, the quantity, right, that can economically be manufactured, batch size. Let's begin to take a look at 2 examples to put these perspectives into context for this class. Let's take a connecting rod that is used in the automotive industry. We have looked earlier on into material indices that go into connecting rods and designing for that. Suppose based on that, there are constraints that are identified through that analysis of different dimensions, different materials, and so on, and we down selected it to a non-ferrous alloy, something that's not made out of a steel, and something that's not a composite, for instance, or a ceramic. The second part is the shape, right? This is a solid shape, which is 3D. There's a mass-related constraint, under a pound. Minimum section, which is below a centimeter, about 8 millimeters. Tolerances for these surfaces should be less than a millimeter. I mean, basically, you have enough allowance to be a machine if you need to for that type of a range. Within the bores themselves, they're tighter than that. It's about 0.2 millimeter. Roughness is not critical because you can machine it, or it's not required for the overall use. And batch size, 100,000 is the minimum batch size that's required. So based on this function and constraints, we want to minimize the cost that satisfies these kinds of constraints, but also gives us the cheapest alternative. The variables that are free to work out through these considerations for the design problem are what process can we use, and within that, for any given process, what are the manufacturing conditions for being able to work with that process.